Greetings for Sir Muhammad Fauzi bin Mortar that teaching us DCC 30112 Geotechnical and Highway Engineering Laboratory. Today we're gonna present laboratory for sieve analysis. Alongside with me is Edi Ryan, Ahmad Sirajuddin bin Abdul Malik, Muhammad Shameh Haikal, and we are from Group 4. So the first step is add a weighing machine and a set of sieve from the apparatus menu and weigh each sieve separately by clicking on the set. The weight will be available at the end of the experiment in the conversion table. Each sieve is weighed to account for its weight in future measurement of other components added to it. Add a soil sample from the apparatus menu by clicking the submit button after seeing the soil sample mass to an appropriate value. For this we choose a 241. Then step 3, add the sample to the sieve by clicking on it. However, the soil won't be properly sieved it on and requires some external force which will be provided by shaker in the incoming step.
Okay, so for step 4, add a shaker from the apparatus menu and move the sieve set with soil to the shaker to properly sieve the soil. Next, add a lid to cover the sieve set to prevent soil from falling out. Step 6, start the shaker and sieve the soil sample by clicking on the blue portion of the shaker at the bottom. The vibrations or rotations of the shaker provide the needed external force to truly sieve the soil.
Step number 7. Move each sieve to the weighing machine separately by clicking on the sieve set. This gives us the weight of the soil retained plus sieve for each respective sieve, and we can easily obtain the weight of the soil alone by simply subtracting the weight of the sieve as is visible from the values in the observation tables. After that, check the observation tables. The table presents the observation for different types of soil, where the first table pertains to well-graded soil while the second table pertains to uniform graded soil. Note that each run of experiment, even for the same value of soil mass, may produce slightly varied outputs. This is done to account for the error margin, and generally an experiment is repeated several times and the values are averaged out in the real world.
Okay, so the procedure number 9 is also check the graphs and the corresponding observations. We plot the graph of percent of soil thinner versus grain size for both grades of soil for comparison. We also use the graphs to derive the D60, D30, and D10 values to compute the uniformity coefficient and the coefficient of curvature for both. The procedure number 10 is repeat the experiment for different values of soil sample mass. So that's all. Thank you so much.